Now, as we discussed our naming binary ionic compounds in our video notes, okay, we should have certain things, these objectives, hopefully you will be able to meet by the time we are completed today. First of all, you should be able to identify a multivalent ion. You should be able to use the stock system of nomenclature. And the stock system is dealing with Roman numerals. You should be able to name and write formulas using polyatomic ions. And finally, you should be able to name binary ionic compounds. So hopefully those 4 objectives will be met by the time you leave here today. A multivalent ion. Okay, a multivalent ion. Sometimes elements have 2 or more cations. And remember, when we're talking about cations, we are dealing with metals. Metals are the ones that want to get rid of electrons. When they get rid of the electrons, they form positive charges. All right? We'll be doing a lab later on in the week which is dealing with 2 different ions of iron, iron 2 and iron 3. Now, when we're discussing multivalent ions, we need to look at the oxidation states on the periodic table. So, look at your periodic table. Okay, if you are using the smaller periodic table, if you're using the little periodic table, it will be black numbers above the symbol. Okay, so look for the black numbers above the symbol. If you are using the larger periodic table, oxidation states are on the bottom right, the second one up. All right, so let's first of all look at lithium. Look at lithium. I find the oxidation state for lithium. What does it say? 1. How many numbers are there? 1. So, lithium would not be considered multivalent. It only has 1. Now, let's look at something. The one we're going to be dealing with in lab this week is iron. So, look at iron, number 26. What are the oxidation states for iron? And I believe they're different between big table and little table. Okay, if you have the little table, what are the oxidation states for iron? 2 and 3. If you have the big table, okay, it says 2, 3, and 6. Correct? So these are different. They could be different based on the periodic table you have. Now, obviously, 2, 3, and 6 are more than one number, right? Therefore, iron would be considered multivalent. It takes more than one charge. So, if we are looking at those oxidation numbers and there is more than one oxidation state, it is considered multivalent. Look at chromium. Chromium has, what, a 6, a 3, and a 2 on the big periodic table. Check out manganese, number 25, right in between chromium and iron. It has, what, 7, 6, 4, 2, 3. So it takes 5 different charges, possibly. Okay? So, when we are dealing with multivalent, okay, we are looking at oxidation states. Now, remember I told you that we are dealing only with metals here. Only with metals. Let's look at something, a non-metal. Look at chlorine. Okay? Look at chlorine. Chlorine has a plus or minus 1, 3, 5, 7. Okay? A 1, 3, 5, 7, but when we're talking about these multivalent ions, we're talking about metals. Okay? What ion will chlorine take? Okay? If you got to say the chloride ion, it would be what? Well, we talked about this the other day. Okay? Well, the chloride ion, what charge is it going to take? -1. Why does it take -1? Because in order to fill its octet, it needs 1 valence electron. So all of the halogens are going to take a -1. So we're only dealing here with metals. Okay? Let's say, look at lead. Look at lead. First of all, is lead multivalent? Okay? Lead is element number 82. Is lead multivalent? Absolutely. What charges could lead take? 2 and 4. Correct? Here we go with iron. We talked about iron. Iron has a 2, a 3, and a 6 for its oxidation states. Okay? 2, 3, and 6. Iridium. Okay? Iridium, IR, element number 77. Okay? It's going to have oxidation states of 2, 3, 4, 6. So we are looking at those oxidation states to determine whether they are multivalent or not. Why do we need to know this? Why do we need to know this? Do you think that iron 2 and iron 3 are reacting exactly the same? They're not. Okay? Do you think that iron 2 and iron 3 react with other elements the same? They do not. Okay? So it is important to be able to signify which iron we're dealing with. Which iridium are we dealing with? So we have to signify which one. Therefore, we have to be able to tell whether something is multivalent or something is not. The stock system of nomenclature. Okay, the stock system of nomenclature uses Roman numerals. What does it use Roman numerals for? It uses Roman numerals to indicate which the ion's charge is. Okay? The numeral is enclosed in parentheses and placed immediately after the metal's name. Now, if something is multivalent, you need to put a Roman numeral. If something is not multivalent, you do not put a Roman numeral. We talked about lithium. Lithium only had a +1 charge. Okay, its oxidation state was only 1. We don't need a Roman numeral because it's the only one it can take. If you would put a Roman numeral after lithium, it would be incorrect because you do not need one. We talked about iron, okay? We talked about iron here. Iron 2+ would need Roman numeral 2 after the iron. Iron 3+, we would have Roman numeral 3 after the iron. Iron 6+, we would have Roman numeral 6, a VI. Signifies Roman numeral number 6. So if it is multivalent, we need Roman numerals. Once again, we talked about lead. Lead took a +2 charge, lead 2. Lead took a +4 charge, so that would be lead 4. So the stock system of nomenclature gives Roman numerals to indicate the charges. Okay, so when I see that Roman numeral behind the word iron, I know that since that is 3, we are dealing with iron 3. Latin names. Okay? Latin names, if you look on your polyatomic, or excuse me, on the ion sheet that looks like this. Okay, the ion sheet looks like this. It has a periodic table on the top. You can see that it has, down at the bottom, metals with more than one ion. Those are not the only ones. It's just a list of some of them. Okay? It's just a list of some of them. So you will see stock system on the middle column. For instance, chromium 2, chromium 3 are the top 2. But it also says that there's a classical system. Okay? This classical system we don't use much anymore. Okay? We use the IUPAC system, which has Roman numerals. But you could possibly see at time to time an OUS ending or an IC ending. That is the older system. Okay? That is the older system, where the OUS is the one that has the lower charge. Okay? Chromus or chromic. Chromic, the IC, would have the greater charge. Okay? It is harder to tell. It is harder to tell because Roman numerals are real easy. The Roman numerals right behind the name. Okay? If I have an OUS or an IC, I have to go to my periodic table. I have to look at my oxidation states and say, okay, what's the biggest one? What's the smallest one? Okay? Then it further brings problems because we talked about iron. On one periodic table it says 2, 3, and 6. On the other it only has 2 and 3. So this just brings a lot more problems that are involved. Okay? Now, some things, and I don't remember whether we talked about it in here or not, but lead. Lead. Why on earth would lead have the symbol of capital P lowercase b? Well, that's from the Latin name. Okay? That is from the Latin name plumbus. Plumbus. We look at some other ones. Okay, mercury is Hg, gold is Au, silver is Ag, tin is Sn. Those are all coming, they're stemming from the Latin words. That is why they don't usually make sense. Where did tin, T-I-N, get capital S, lowercase n? All right, so these Latin names, okay? Here is gold, Au, auric and aurus. Okay, plumbic, plumbus. So I can see that the IC tells me it's the higher one. The OUS tells me it's the lower one. A polyatomic ion. Let's break down the word. Poly is many. Many atoms. So an ion that has many atoms. These polyatomic ions end usually in ATE or ITE. So find the ion sheet that I gave you that has a polyatomic ion list. Okay? Polyatomic ion list, and go through and look at the endings. Most of them are ATE or ITE. The only other one, if I remember right, is a couple of them have an IDE ending, such as cyanide. But most of your polyatomic ions are going to be ATE, ITE. What they're dealing with is the amount of oxygens. When a polyatomic ion is given an ATE ending, that is the most common of the ions. The ITE ending has one less oxygen. So if you would look at sulfate, sulfate is SO4 2 minus. So the ATE, the SO4 2 minus, is the most common of the polyatomic ions. The ion with one less oxygen, SO3 2 minus, we've just taken off one oxygen, SO3 2 minus is sulfite. Sulfite. Here's NO2. Find NO2 on your polyatomic ion list. Okay, NO2 is what? Nitrite. ITE. So this would not be the most common one because the most common one's an ATE ending. Okay? So how does nitrite and nitrate differ? Well, the ATE is going to have one more oxygen. So NO3 minus 1 is the nitrate ion. Sometimes two elements form more than two different ions. And what I usually do is I deal with the chlorate ion on this one. So you're going to see hypo that goes with the ITE and per, which goes with the ATE ending. Well, what do I mean by that? Well, we're going to just go exactly to chlorate. There are 4 different derivatives of the chlorate ion, and it's all dealing with how many oxygens. And here are all 4 of them. So if we look at chlorate, chlorate is ClO3 minus 1. If we take one oxygen away, it's going to be ClO2 minus 1, and we would call that the chlorite ion. If we would take one oxygen off of the chlorite ion, it would be hypochlorite, and it would be ClO minus 1. If we would add, if we have added one oxygen onto the chlorate, it would be ClO4 minus 1, and that would be the perchlorate ion. So find those ions. They're all right there. Well, I guess they're not all right there in a row, are they? Okay. But find chlorate, chlorite, hypochlorite, and perchlorate. All right? I would like those, it makes more sense, and maybe you want to do this sometime, to write those all at the bottom of that ion list in order, because there you will have them all together. And why? Why do I need to have these? Let's stop. What if I would have something that said it was, and you'll see this, periodate. Periodate. Well, if I knew what the iodate ion was, I would know that the periodate was just one more. I don't know, is periodate on there? Yes, it is. Okay? But if I know these, and I know one of them, okay? So if I have bromate, okay? If I had bromate, which is BrO3 minus 1, then I would know what perbromate was, I would know what bromite was, and I would know what hypobromite was just by adding or subtracting oxygens. Okay? Just by adding and subtracting oxygens, I would be able to tell which is which. Okay? So, I think it's a good idea for you to write those in order on your periodic table so that you have them all there as a group so we can see, okay, this is how this goes, and we're adding oxygens to it to make up the differences. Okay? Now, I don't think we're going to have a bunch of time left because we get out of here a little bit earlier. But naming a binary ionic compound. Binary means it's two elements, and this is an ionic compound. Now, how do I know something is ionic? How do I know something is an ionic compound? It is dealing with metals and nonmetals because we are gaining and losing electrons. Look at this right here. What two elements am I dealing with? What is Cu? Copper. What's Cl? Chlorine. So I'm dealing with copper and chlorine. Well, as I'm naming this, okay, I look and I say, okay, I have the name of the cation. Do I need a Roman numeral and then the name of the anion? So, what is my name of my cation? Copper. We just said that. Now, is copper multivalent? Yes, it is. So, do I need a Roman numeral? Yes, I do. So, how am I going to tell what copper I have? What are my two choices? What are my two choices for this, for copper? +1 and +2. Looking at my oxidation numbers. So how am I going to tell which copper I have? Well, I need to look at the chlorine because I know what charge chlorine is, don't I? What charge is chlorine going to be? What is it? -1. How many chlorines do I have? 2. So what's my total negative charge? -2. So what copper must I have here? +2, because I only have one of them. So how am I going to signify that it is copper +2? I'm going to put Roman numeral II. So my name would be copper 2 chloride. Remember, the negative ions, we talked about this last week, the anions replace with an IDE ending. So chlorine turns into chloride. Okay, oxygen turns into oxide. Nitrogen, nitride. Okay, bromine, bromide. Okay, so we have the IDE ending coming in. Here's a polyatomic. Okay, I know that I have potassium. Potassium is a metal. OH is a non-metal polyatomic. Okay, so I am dealing with potassium. What is the OH ion? Find it on your ion lists. You will eventually have this into memory. OH is hydroxide. So I check, is potassium multivalent? Is potassium multivalent? No. What charge does potassium take? +1. What charge does hydroxide take? What charge does hydroxide take? -1. So I've got a +1, I've got a -1. Okay, they're equal. It's not multivalent. So what I'm simply going to name this is potassium hydroxide. Okay, potassium hydroxide.